All right, good morning, good afternoon, good evening, good morning, good afternoon. We're actually doing the last video, and we're talking about zero product rule. I think last video I unfortunately canceled. I pushed the wrong button and it canceled on me. So it didn't cancel, but it stopped the recording, and I just figured I would continue on in this video with those examples. So we're solving equations. Solving means tell me what x equals, or whatever variable is in the equation, you got to tell me what that x is equal to, or y is equal to. That means solving the equations. And we're using the zero product rule. Zero product rule means that if a times b equals 0, then either a equals 0 or b equals 0, and we're going to finish up those examples as well. Alright, so let's go close that out, and we'll go back over here. I suppose we'll go back to the beginning and say, you know what, here's the zero product rule. Quadratic equation means that quadratic, we've got a quadratic part here, and we've got an equation part here. Quadratic means it's the variable is squared, and that's the highest variable that we've got, our highest degree on the variable. And the equal sign is in there as well, and that makes it equation. So here's a quadratic equation. Here's a linear equation with ax to the first power. Alright, and then here's our zero product rule, and it's highlighted in red, it's highlighted in green, and I suppose this time I'll just highlight in blue because you know what, that'll be something that'll be really pretty important to know. If a, and here's the zero product rule, if a times b equals 0, then either a is equal to 0 or b is equal to 0. Because if a is equal to 0, b can be whatever it wants and it's still 0. If b is equal to 0, a can be whatever it wants and the equation is still equal to 0. Alright, that said, let's go and finish up those two examples that we had to figure out. So number one is our question here. On the left side, I've got 5x times the quantity 5x plus 2 equals 10x plus 9. Alright, can we do anything with the zero product rule right now? The quick answer is no, because not right now. It's kind of like you can't get there from here. But what you have to do is kind of simplify everything, and then what you have to do is push everything to the left, or to one side, and then the other side should be equal to 0, and then factor the side with all the terms on it, and then one of those factors is equal to 0. So let's just simplify this as much as we can. We're going to distribute the 5x to the 5x and plus 2, and we get 25x squared plus 10x equals 10x plus 9. Alright, so there's our first step to do, I guess, is make things into terms. Distribute that 5x to the 5x plus 2, and now we've got a quadratic equation. Because we've got a quadratic, here's an x squared term, and we've got an equation here, and in order to solve the quadratic equation, we need to use the zero product rule and put everything on one side and 0 on the other. So I'm going to say, because 25x squared is positive, we'll keep that over here and we'll move everything to the left. So to do that, I guess next step would be subtract 10x, subtract 10x. And what do we have? I got 25x squared equals, these cancel out, equals 9. And then we move the 9 over by subtracting 9 over here and subtracting 9 over here. And what do we have? I've got 25x squared minus 9 equals 0. And now can we use the zero product rule? Yes, we can, but not quite yet, because we have to factor this over here. How can we factor that? Well, let's see. We can use the AC method, I suppose, but this is a special one. If we look back to chapter, I think 6.6, 6.6 talked about those special properties, and the one that I'm talking about is difference of squares, because this 25 is a perfect square, x squared is a perfect square because 2 is even, 9 is a perfect square, it's 3 times 3, and so we've got a perfect square here, we've got a perfect square here, and it's separated by subtraction. Anybody remember what that is? Yes, it's difference of squares. So if we do that, then we factor this 25x squared minus 9 into 5x minus 3. It's the first term here is the square root of this entire term. 25x squared square root is 5x. 9 square root is 3. And then we do the same thing over here, and it's 5x plus 3 equals 0. And there's our factorization of the difference of squares. And now if we've got a times b equals 0, either a is equal to 0 or b is equal to 0. So we set up some mini equations and we say either 5x minus 3 equals 0 or 5x plus 3 equals 0. And we solve that by adding 3 to each side plus 3 to each side, and we get, I'm going to write over this stuff here, 5x, let's see, equals 3. And hang on just one second, I want to see if I can move this down. There we go, we'll get some space there. We'll create a little more space later on too. 5x equals 3, divide by 5 on each side, we get x equals 3/5. And that's one answer. Or, let's see, subtract 3 over here, subtract 3 over there, and we get 5x equals negative 3. Divide by 5, and we get x equals negative 3/5. And it's an or statement. Either x equals 3/5 or x equals negative 3/5. And to confirm this, we would take these values back up in here. That's kind of a complicated one to do it. So to double check your work. So what I would do is say, well, I tell you what, did I distribute correctly? 5x times 5x, 25x squared plus 10x, yep. And then did I move the 10x correctly? Did I move the 9 correctly? Yep. Did I factor that correctly? Yep, looks right. And then we say from here, 5x minus 3 equals 0, 5x plus 3 equals 0. Did I do that correctly? Yep. Did I do that correctly? Yep. So I double checked my work. So there's my answer, 5x, or sorry, x equals 3/5 or x equals negative 3/5. All right, now for this one, the one on the right, I'm going to say you pause the video, do this one, and in fact, I'm going to make this homework as well. This shouldn't be that difficult. Here's our homework question. So do that as homework. It's very similar to this one over here. Make sure you distribute that 4z to each side, to the z plus 3. Move everything to one side, set this other side equal to 0, factor the left side equal to 0, just like over here. Then one of these a or b is set equal to 0 for the zero product rule, and solve the mini equations, and you've got your answer. All right, so that said, there's your homework. Last thing to know, last thing to work on, I guess, is we can expand our application of the zero product rule to a higher degree polynomial like this one here. So if we go back and say, well, let's use this one here. If I've got something like this, 5x minus 3 times 5x plus 3 equals 0, that came from a quadratic, an x squared term. Later on, we'll be able to factor different things like cubes, but right now we can factor squareds. And if we've got this, if we're given this in blue, or we're given this in green, we can use the zero factor property because we know that either a or b equals 0. But we can use the idea of the zero factor zero product rule on a higher degree polynomial, especially if it's factored like this. So if we factor something like this, or if we're given something like this even, this would multiply out to a cubic. We'd eventually have like a y cubed, actually, but negative 6y cubed dot 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 equals 0, because all this stuff over here would multiply together to get a y cubed. But it's not so important to know that it's a y cubed product, but it's more important to say, you know what, I could use that zero product rule right down here, because I've got a factor times a factor times a factor times a factor, and if we called this a and this b, we could call that c, and then our zero product rule, as long as things are factored, might be expanded to say if a list of factors multiplied together equals 0, then one of those factors is 0. So this could be 0, a could be 0, y plus 3 could be 0, b could be 0, c could be 0. So if we're asked to solve this, we would say, all right, well, I could say that, well, either negative 6 equals 0, and that would never happen, because that is a factor of this entire side, this entire expression, but it would never happen that negative 6 equals 0, so we throw that one away. But we could say that y plus 3 equals 0, or y minus 5 equals 0, 0, or 2y plus 7 equals 0. And then we'd solve each of these mini equations. We could solve this by subtracting 3 from each side, and we get y equals negative 3. We could solve this one by adding 5 to each side, and we would get y equals 5. And we'd solve the last one by subtracting 7 We get 2y equals -7. Divide by 2 to get y equals -7/2. And that would be our answer for all three of, actually the three possible solutions for this equation. Because if we put y equals -3, -3 times 3 is 0. This is 0. 0 times anything is going to be equal to 0. Y equals 5. 5 minus 5. This is 0 times anything equals 0. Y equals -7/2. -7/2 times 2 is going to be -7 plus 7 is 0. This is 0 multiplied by anything else is going to be 0. So we can use the zero product rule on a higher degree polynomial when it's factored. And if we know how to factor it, we can use it. But if it's given to us as a factored expression, then we can use the zero product rule as well. All right, questions? Bring the class. Bring the homework. All right, sorry. Take a copy of or take a picture of your notes and include your homework list, homework question, and put it in my Dropbox, and we'll see you in class.